Thank you very much. It's going to be hard to outdo the introduction, actually. Anyway, on this engraving, you see the three forms of matter that we're most familiar with. You have the solid wood of the ship, the wild water of the sea, the howling wind through the rigging, and yet the sailor's attention is focused at the St. Elmo's fire, at the tip of the yard. The St. Elmo's fire is actually an example of a fourth state of matter called a plasma, not to be confused with a blood plasma. And a plasma can be characterized most easily as a gas consisting of charged particles, which makes for collective behavior. And it usually manifests itself in a beautiful display of light. And indeed, as we can see, a universe without plasmas will be a very dark place. Especially given the fact that over 99% of the visible matter in our universe is made out of plasma. From the start of a universe with the Big Bang, through the dusty plasmas that form the cradle of stars, to the interstellar clouds, to the galaxy, and even to our own little sun, which is of course the source of all life on Earth through the energy and the warmth that it provides us with. It's all plasmas. Also, looking closer to home, we can find examples of plasmas. We've already seen a slide of the Northern Light, but a more common example is, of course, lightning. And lightning used to be the most important source of fire before we mastered the art of making it. In ancient civilizations, the task, the job of guarding a fire, making sure that it didn't go out, was a very important one. And the mastery of fire is actually something that sets us apart from animals. Most animals are afraid of fire, as are some little kids. I, for instance, as a little boy, I still remember when we were making a big bonfire in our backyard with my father, and I was both drawn towards the flames and the fire, and at the same time scared of it, of the crackling sound and the licking of the flames on the branches. And the fiery flame, the fiery plasma of a flame, not only provides us with warmth and comfort and safety, it also provides us with light. The romantic form, which is something that I have a difficult time to grasp, being a physicist. But this is an example that every one of us is familiar with. The very common fluorescent lighting in our daily offices that allows us to do our jobs, that has actually transformed civilization. Everywhere on Earth where electricity is introduced, people's lives change drastically, most of all because of the light. But the mastery of fire also provided us with something else, the ability to process materials. Nowadays, plasmas are used in a wide variety of processes to make things from anti-reflective coatings on lenses, surface treatments for parts of the engine in your car, and even solar cells. They also provide a very convenient source of UV light, which can be used to purify water, to make clean drinking water, from small handheld devices such as this one that you can take on a hike, to large industrial scale processes that are able to provide clean drinking water for entire cities or even countries. Other examples of this application are exhaust gas treatments in power plants or purification of air in large buildings and air conditioning and climate control systems. Plasmas also do have medical applications. They're usually used for sterilization of equipment and for treatments of wounds that would otherwise be very slow to heal or possibly not even heal at all. However, plasmas also provide an endless source of fun and entertainment. Who of you hasn't felt a little bit like a magician or like a wizard when playing with such a toy and having the plasma magically follow your hand over the sphere? Or who of us hasn't spent many an hour watching such a device, which may be mounted on your living room wall, enjoying a good film, show, documentary or match. And one thing that all these applications have in common is that they require energy. And quite a lot of it, in fact. If we look at an image of the Earth by night, you can imagine, by looking at all the little specks of light, just how much energy is needed. And up till now, we've been using solar energy condensed in the form of fossil fuels. But wouldn't it be nice if we could make our own little sun on Earth, harnessing the enormous potential of nuclear fusion? That is something that I'm actually working on at Eindhoven University. Here you see an example of a fusion plasma in Mast, a test reactor in England. But also at Eindhoven University, we have our own little fusion reactor that we can use for research. And looking even further into the future, from ever since humanity grew up, when we looked at the night sky, we had this dream, this fascination of one day being able to go there, being able to travel to the stars. And we already have probes that are being propelled by plasma. And one thing we know for sure, if we're going to explore a galaxy, it won't be in spacecraft propelled by rockets. Already they're testing a prototype of a plasma thruster for a trip to Mars. So perhaps one day plasmas will not only light our world, power our civilization, but it will also allow us to reach for the stars. Thank you very much.